Today's lesson is on simple interest. This is actually a fairly easy topic. Our objectives are we're going to talk about what simple interest is. We're going to calculate simple interest. We may or may not do objective 3. I'm not as concerned about that one. We definitely will look at number 4, which is making comparisons using simple interest. So first, we're going to look at the formula for simple interest. Simple interest is one of the percent things that it does not work so well to use a proportion when you do this, so you need to use the formula. The formula is I equals P R T. Make sure you write that down exactly the way it is written. When you take the PSSA, they will give you this formula, so you don't have to memorize this. It's one of the things that's on the formula sheet that you can look at. So any problem that I give you on a test will also include this formula, so you do not have to memorize it. I stands for the word interest. P stands for the word principal. You want to make sure you spell that with A-L at the end, just like you spell the principal of a school. R stands for rate. And T stands for time. Interest is something that can be good or bad. You may have to pay interest, so interest can be paid, or you may earn interest. Can anyone give me an example of something you would pay interest for? Brayden? A car. When you buy a car, you don't have to pay interest, but most people don't have enough money to just pay the whole amount for the car. So most people take out a loan and they have to pay interest on the loan for their car. So their car ends up costing them a lot more in the long run than what it should have. It's ideal if you can save lots of money and pay for everything in cash. You save a lot that way, but most people can't do that. Any other examples of when you might pay interest? Adria?
Taking a loan out of the bank and doing that.
Yeah, taking any loan out, you're going to pay some degree of interest. Irene?
Like if you buy a house.
Yeah, house is a very important one. House interest rates are usually fairly low, but because you pay them over such a long time, you pay a lot of interest for your house. Most people pay more interest on their house than the house was originally worth. Violet?
It's in college one because you have to pay school loan.
College, if you take school loans, yes, you have to pay interest, unfortunately. You can defer your loans, but the interest just keeps on rolling on. So yeah, interest is not such a happy thing. Another place you might have to pay interest is credit cards. Credit cards usually have very high interest rates, and if you use credit cards and you don't pay them off at the end of the month, a lot of times when you make your minimum payment, it only goes to cover the interest. And so you never get out of debt unless you pay more than that minimum payment. Now they have recently raised minimum payments so that it does, but it takes a really, really long time to pay off credit card debt. All right, principal is the amount you borrow or deposit. So in the case of borrowing money, if you were buying a car, principal, say the car cost $8,000. The principal would be $8,000. Then you would also pay interest on top of that. The principal is just the original amount. If you were putting money in a savings account or you were investing money and you invested $1,000, that's your principal. It's the original amount. Rate is the percentage, missing one here. It's the percentage you either pay or earn. So for each of these things, there is a percentage rate that is used to calculate the interest. So we have the principal times the rate. Time is kind of self-explanatory. You all know what time is. This is usually in months or years. Mostly it's a monthly interest rate if you're looking at things like credit cards, but most of the examples we'll be doing will be yearly. Okay, let's take a look at an example. You borrow $3,000 for 5 years at an annual interest rate of 4%. How much will you pay in simple interest? Now, I'm going to tell you that this is not a realistic problem because if you borrow $3,000 for 5 years, you are probably going to pay more than 4%, usually more than that. That's more typical of what you might be able to get a mortgage for, but as far as borrowing money, you're probably going to pay more. All right, so we're going to use our formulas. We have I equals P R T. So you just have to identify what parts you have up here. You borrowed 3,000. What part is 3,000? Which letter in the formula goes with 3,000? Volunteer? Irene?
Would it be the principal?
It would be the principal. That's the initial amount that you borrow. How about 5 years? Violet?
Time.
Time. An annual interest rate of 4%. Grace?
Would it be R?
It would be R. It would be the rate. It's telling you the interest rate of 4%, and it's asking you how much you're going to pay in interest. That's our I. So you're finding I. Most of the time you'll be finding interest. Once in a while we'll get a problem where the interest is not given. That's a little trickier algebraically. So all I do is I take the numbers and I plug them in. 3,000. Now when you get to the rate, this is written as a percent. I have to change that percent to a decimal in order to use it in the problem. That's probably the trickiest thing to remember. So 4% is 0.04 times the time, which is 5 years. You may use a calculator when you do these problems. You would multiply 3,000 times 0.04 times 5. You would get an answer of $600. Okay, the next slide is an example for you to try. There's also a challenge example. So I want you to think about the challenge. I don't expect all of you to be like, oh, okay, this is how you do the challenge. It's going to take a little more thought, but give it a try, and we'll talk about that in just a minute. Okay, Ross. $5,500 is which part of the formula? P. Sky, 6.25% is what part of the formula? Good. And 3 years. I'm just going to give you this. It's too easy. Time. Okay. Kaylin, tell me how you set up the formula.
5,500.
Okay, let me put I equals first. Okay, 5,500.
0.065.
Good. And 3. And what did you get as your answer?
$1,013.25.
Good. How many of you got that answer? Okay, excellent. Did anybody, I'll take volunteers on this, complete the challenge? Let's see. Dakota.
I got you would save $82.50.
Excellent. Tell me how you did that.
So all I did was I got I equals 5,500, and then I put in the 0.0575,
Okay.
and then I got 3,
Okay.
and I multiplied them all,
Mm-hmm.
and I got 948.75.
Okay.
And then I did 1,031.25 minus 948.25.
For your answer of 82.50. All right. Excellent job. How many of you did the challenge and got $82.50?
I wouldn't have messed up the first.
Okay. So you understood how to do it. Okay. Excellent. You're going to take a look at objective 3. We may go through this fairly quickly. This is just graphing simple interest, and this is kind of interest because this relates to what we've done with proportional relationships somewhat. The example says you have $500 in an account that earns an annual rate of 5.1%. At the end of each year, you withdraw the interest you have earned. Graph the total interest you earn after 1, 2, 3, and 4 years. So we're going to use years or time as our independent variable. and the amount of interest we earn as the dependent variable, because the total amount of interest is based on the amount of time. So this will be in dollars, this will be in years. Okay, so after the first year, you would have the principal times the rate times the time, which is 1. Okay? When you multiply 500 times 0.051 times 1, you get $25.50. Now the only thing that changes for year 2 is the year. So you have the same equation for year 2, only the time is different. So for year 2, how much interest would you have earned? Violet?
$51.
$51. That would be the total interest. Now, the only thing that's going to change is our year. So essentially what we have up here is I equals some constant number. What is 500 times 0.051? Just 500. Oh, it's 2550, right? Mm-hmm. So we actually have 2550 times the time. What kind of equation is this? Think back. Jake?
It's simplified. I have no idea.
It is simplified, but it's a specific kind of equation. We use different letters a lot of times in this type of equation. Violet?
Is it a one-step equation?
It is a one-step equation, but it represents a certain type of relationship. Irene?
Algebraic.
Yeah, it is algebraic because it has a variable, which is time, but Eli? Proportional relationship. Remember y equals kx? Remember that? That's the type of formula that represents a proportional relationship. This is y equals kx with I instead of y and t instead of x. It's just using different letters. We end up with a constant. So we could continue to use the equation, or we could look down here. How could we find out how much interest there would be after 3 years? Violet?
Multiply $25.50 by 3.
By 3? Yep, we could do that. And what would we get?
$76.50.
Good. And then to get to the next step, Irene?
Just take 50. You could multiply, but what I did is I just took 51 times 2 and got 100.
Okay, so you took 2 times 51. That works too. So you get $102. All right, take a break. We'll finish this when we get back. Okay, before we draw the graph, knowing that this equation represents a proportional relationship, who can tell me what the graph is going to look like? Jake.
Through the origin, a straight line.
Straight line through the origin. Excellent. So we're expecting a straight line through the origin. That's what we're going to get. So we're going to put our time in years. That's our independent variable. We're going to put it on the x-axis. I'm just going to label 1, 2, 3, and 4. This y-axis, the dependent variable, is interest. What kind of numbering system should I use for the y-axis, do you think? What should I go by? Adria?
25.
By 25? Yeah, that's what I did. I like 25s. Because I need to get all the way up to 100. I don't have very many of these lines, so if I go by 25s, that works well. And it does go above 100, so it's useful to have 125. So after 1 year, we have $25.50. That's like almost on the 25. After 2 years, we have $51. That's just slightly above the 50. After 3 years, we have $76. That's just above the 75. And after 4 years, we have $102. Again, just above the 100. So it does form a straight line, which we could continue that line, and then we could use this graph to predict future amounts. Okay, any questions about that? Now, I should tell you, in the real world, this is based on simple interest. Most people do not withdraw their interest. If they have a savings account, they leave their interest in the account. So if they leave it in the account, it's not going to be a straight line. It's not going to be a proportional relationship because the amount that's in the account will change every year. The principal will change. So it will actually grow a lot faster. It's called compounded interest because your money grows faster if you leave your interest in there. All right, we are going to skip this one, but if you want to do it on your own and you want to try the challenge, I'd be interested to talk about it with you. We are going to go on to objective 4, which is making comparisons using simple interest. So the example we have is comparing two loans. You need to borrow $1,000. You can borrow it for 3 years at 8% simple interest or for 2 years at 11% simple interest. Which loan will cost more? Okay, so how do you think we should get started with this? How are we going to figure out which loan costs more? Adria?
By setting them up in the formula and then solving each equation.
Good. Setting them up in the formula, solving each equation. So let's take a look at that for the first scenario. The first scenario, our principal is $1,000. Our rate is 8% for 3 years, so we do 0.08 times 3. When you do all that, you end up with $240. So that loan, the interest that you're going to pay is going to be $240. Now, the next loan has a higher interest rate, so you might think, ooh, it's bad to have a higher interest rate, but it's less time. So let's see what happens with that loan. We still have the same principal amount. Now we have 11% interest for 2 years. When we multiply all of that, we get $220. So it looks like the first loan, the 3-year loan, actually cost more. So even though the rate was lower for the 3-year loan, it ended up costing more because it had a longer amount of time connected to it. Now, where this is a good thing is when you are saving money, it's good to have a lot of time, to save money over a lot of time because you pay less interest. It's interesting, though, in the real world, how this works. Usually, if you get a loan for a shorter period of time, it actually has a smaller interest rate as well, which is kind of the opposite of what you would expect. You would think they might want to charge more money so they could get more money, but they like you to borrow for less time. So, for example, if you're buying a car, a lot of times my credit union for a while had something like a 2.5% interest rate if you borrowed a loan for 6 years. But if your loan was only going to be 4 years or less, the rate might be 2.25%. If you were going to borrow it for 2 years or less, the rate was like just 2%. So it actually got less as you borrowed for less time. All right, one more example for you to try. All right, let's take a look at this. Kaylin, how much does the first loan cost? Good. The first loan costs $420, the one that you're doing 7% simple interest for 3 years. How much does the second loan cost? Violet?
$440.
Good. Second loan costs $440. So obviously the second loan costs a little bit more. And that one had a lower interest rate for a longer time. So you could kind of guess that that was going to be less. So the 2-year loan will cost more. All right, that concludes our lesson.